or anything that you guys would like to talk about, whether it either be part of today's session or even if it's anything outside of the scope. Excuse me. Okay, so today the learning objectives is first to identify the key components of a good quality management system. We want to describe some QC principles and the application in the routine microbiology laboratory. We want to recognize some common QC failures and how we can prevent them, and also lastly to apply the relevant QCs to specific tests in the laboratory. So first we'll talk about quality management systems. So how is this defined? We keep talking about LQMS. So LQMS is a framework and it integrates all the laboratory processes and resources to ensure that we have consistent production of accurate, reliable, and timely test results. We also want to support patient safety and continual improvements. So before we can actually look at having a good LQMS, what we need to consider are some laboratory requirements. So depending on the type of laboratory that you work in, the requirements might be a little bit different, but this is good to keep in mind. So the first one is some international requirements. So I know that in Cambodia, we're trying to do a lot of, accreditation and be ISO accredited. So some of you will be very familiar with ISO 15189, which is the medical laboratory requirements. And this is mainly for quality and compliance. There's also 17025, which is for general requirements and testing, particularly calibration. And some of you may have heard of SLIPTA and SLIMTA as well, which is a WHO LQMS framework. There are also some national requirements. So depending on where you are, or if you would like to adopt some, in the United States, there's the Clinical Laboratory Improvement Amendments. And in Australia, we have the National Association of Testing Authorities, which is called NATA. There are also requirements for transportation of hazardous materials. So national and international requirements for this transport. And most of you will be quite familiar with the International Air Transport Association, which is IATA. There is, most importantly, safety requirements. So the safety requirements that affect the laboratory. So whether that determines whether you are a PC3 or PC2, and what safety requirements do you need for the work that you are doing. So in Cambodia, I did some research. There's a Ministry of Health Laboratory Biosafety Guidelines that you might be working with. In Australia, we have work health and safety legislations, and the WHO also has a laboratory biosafety manual that we can get some requirements from. Lastly, there's also international accreditation. So there are internationally applied accreditation requirements, and this can be from, for example, Joint Commission International or a College of American Pathologists. So these are some examples of some laboratory requirements. What consists of our laboratory quality management system? So it's made up of what we call quality system essentials. And these are based on CLSI, and there are 12 recommended quality system essentials. So very briefly, the first one is organization and the leadership. So this talks about lab structure, leadership, responsibilities. Thank you, Vendra. I forgot to record them again. So
the recording has stopped.
We'll go into a bit more detail later on, but just to go over the
this meeting is being recorded.
The second one is personnel. So this ensures that the staff are qualified and trained, are competent, and receive ongoing professional development. We then have equipment. So the selection of the equipment, calibration, maintenance, and validation when it comes into the laboratory. We also want to look into supplier and inventory management. So these are things like your reagents, consumables, and so on. We have process management, which controls all the testing processes. Information management, so all the data that you generate, the records, reports, how can you access them? How secure is it? And if it's accurate. Documents and records. So this ensures that all the procedures are controlled, the policies, forms, manuals, everything is consistent and traceable. Non-conformance management. So when there are non-conformances in the laboratory, how are we identifying them? How do we investigate them? And what documentation do we have to address these errors? We also have assessments. So these can be in the form of internal or external assessments. And these could be things like your external quality assurance programs, so your EQA, and management reviews. Process improvements, so implementation of corrective and prevention actions, including your continual improvements. Customer service, so to monitor and respond to the needs of your clinicians, patients, and other users. And lastly, facilities and safety management. So to ensure that we have a safe, secure, and suitable lab environment. So all these 12 items make up our quality system essentials, so our QSEs. Excuse me. I can have a bit more detail. So for our first QSE, our organization and leadership. So it's really important to have an organizational structure to the quality of the laboratories. This leadership, and it's very much important that it can implement the quality management system. We will use it to allocate humans, facility, and material resources for the work that we want to achieve in the laboratory. And we want to perform all the management reviews to review the status effectiveness of the quality management system. It's also really important to have an effective communication plan. So this is this element of the QSE. When we look at personnel and competency, this is where we have a look at recruitment, the orientation and training requirements needed for the staff to ensure that they can complete the work and ensure that everyone's confident. Competency assessment. So you have the initial competency where after someone is trained, we want to ensure that they're competent. There is an assessment for that. And after a while, we have a routine check of how competent someone is. So for example, this could be an annual competency check. So for laboratories that don't routinely do TB staining, for laboratories that don't routinely do ZN stain for TB, they might do an annual competency. So every year, everyone will come together and do a stain for ZN to see if they're still competent in this. Proficiency testing participation. So this is your external quality assurance programs, so your EQAs. Continuing professional development. So coming to sessions like this, the networks of practice, where you're continually to build on the skills that you have. Supervision and delegation of frameworks, and documentation of training and competency records. So all these elements make up this QSE, which is personnel and competency. Another one is equipment management. So this encompasses everything from the selection of the equipment itself, how many of this equipment do we need in the laboratory, the validation. So once we implement or bring in a new equipment, we need to validate that this is working as it should in the laboratory. There are things like preventative maintenance schedules that we need to make sure that the equipment are being maintained well. And you also want to ensure that there are servicing contracts. So particularly for things like your analyzers and like your MultiTOF or your Vitek, or even things like your Vortexer, or things that are routinely used like your pipettes. We want to ensure that there's calibration and function checks, particularly for things that you use regularly. So things like pipettes, you want to make sure that it's calibrated so that the volume that you are aspirating is the correct volume. You want to establish and maintain equipment logs and maintenance records. So it's great that we have schedules and it's amazing if we are doing the maintenance, but it's more important to also document these. So every time you do a maintenance on your equipment, you need to make sure that this is also documented. Out of service procedures is almost as important as when you are bringing in an instrument. When you've decided that an instrument is no longer active or you no longer need it, it's really important to actually go back and what we call decommission equipments that we don't use. Supplier and inventory management. So this is quite important because it has a lot of different layers. The first one is to liaise with your suppliers. So to identify some of the suppliers that you might need for specific reagents or consumables. We want to understand the products, but also to keep up to date with the innovations. So for example, if we were using this test to identify oxidase production for a very long time, it's important for us to understand what the new technologies are out there to see if it's cheaper and also if it's more efficient as well. So a good example for this is a long time ago, people would be using things like a microbat, which is very similar to an API kit for identification of bacteria. But now, if you have the capacity or the equipment for a Vitek, it's actually cheaper to buy a Vitek card for identification than it is to use a more tedious process like the API or the microbat kit. So knowing this type of new innovation and how much it costs and liaising with your suppliers, you'll be able to get that type of information. So part of this also includes procurement of your reagents, consumables, and supplies. So this could be things like standing orders or just ad hoc orders, depending on your need. The storage management of reagents, consumables, and supplies. So knowing how much to order, ensuring that you have enough storage space and that the consumables and reagents that you order are in the correct temperature that they should be stored in. So that's something that needs to be managed. Inventory management, so how you do this, how frequently you want to check your inventory, and what methods is the laboratory using. So things like checklists, so paper checklists people might do once a month, or an Excel spreadsheet, if that's easier for people, or an electronic database. So I know some labs in Cambodia use electronic databases, which is quite good for inventory. But if that's not available, then you can easily use something like a normal paper-based checklist. So process management, we want to ensure that the current laboratory practices and processes are fit for purpose. That's all our clients that require certain tests that we can apply for. So making sure that these are still all relevant. We want to do control testing, making sure that they have those protocols in place. We want to ensure policies, forms, and manuals are all available, and regular and scheduled process reviews are also available. So this is not something like an audit. This is more to see, for example, an annual check, whether someone from management will come in, making sure that we're still reading our plates or culture plates appropriately or storing them for the right duration. So for example, making sure our urine plates are all stored for 24 hours or incubated for 24 hours, and then our blood cultures for 2 or 3 days, depending on what the protocol is. So having that regular check is also very good. We want to ensure the records, manuals, and forms are consistent. So for example, if we had changed something in the SOP, that will also be reflected in whatever forms that need to be filled out, and particularly in our reports as well. Quality control, and also some test methods with the validations and verifications as well. So every time a new test comes in, to ensure that we go through that process of having that validation and verification. Information management. So we want to ensure data, records, reports, and information systems are accurate, secure, and accessible. So what does this mean? I feel like we hear this type of sentence often, but what this might look like in the laboratory, so accurate entry and verification of patient sample and data results. So making sure that if things are entered manually, that these are accurate. Secure storage and backup of laboratory records, timely reporting of results, accessibility for those who require the information. So for example, lab staff, clinicians, nurses, and allied health. But it's really important to note that not all laboratory information is useful for clinicians. So what I mean by this is, for example, in your LIS system or in your worksheets, you might have some information like this E. coli is indole positive. So The laboratory knowing that information, that is useful because someone who comes and looks at the same episode after you can see that, yes, you've tested indole for this E. coli, and it's definitely an E. coli because it's indole positive. Whereas if this information had gone out to a clinician, this is not useful information for them. So therefore, it's very important to have accessibility for those who require that specific information. Management of laboratory information systems. So things like making sure that we have sufficient fields to enter our results, or if there is something that needs to be improved or modified, that we can do this to our LIS system. Most importantly, the protection of patient confidentiality and also other sensitive information. So this is also incorporated into this information management. Document control. So this ensures that the right people have access to the right information at the right time. So similar to the information, but slightly different. So this is more talking about the actual physical records. So you want to ensure laboratory processes are current, approved, and accessible. We want to control the creation, review, and the revision of the documents. So for example, who can make these documents? How will they be reviewed and distributed? And how often are they revised? So SOPs should be controlled and regularly reviewed. So when they're probably should have written revised, but SOPs, once they're made, they actually need to be revised every now and then. So some people do it annually, depending on the test. So for example, if we had a bench SOP, so how to read blood cultures or blood culture SOP, this will likely be reviewed or revised maybe once a year, just to ensure that the processes are still current. Because reviewing and revising our documentation prevents the use of outdated procedures. If you had a new test, so for example, if your lab started using the carbapenem inactivation method, if this is a new test and you would like to revise how the laboratory is doing this test after 6 months, then you would revise it at an earlier date compared to that one annual review. Having this document control will support consistency, traceability, and accountability. And this is very useful for audits. If you have an auditor come and ask you, okay, I see that you are doing this procedure. How do you know what to do? You can just show them the SOP or a job aid or something that you are using to follow this procedure. It's also very good to manage your record retention and storage, and also to facilitate the compliance with some accreditation bodies. Non-conformance is a very large portion, and it's very important because oftentimes it's overlooked. So the definition of a non-conformance or incident types include areas, some near misses. So near misses would mean things that are not quite incorrect, but they were almost there. Any complaints that come from clients, so other clinicians or other stakeholders, and deviations from your process and protocols. So there's a few things that you need to do for this. You need to identify the non-conformance, have a look to see if there's any document errors, incidents, and quality issues. We need to investigate the cause of the non-conformance and to also implement the correction action to prevent reoccurrence. After we put in these correction actions, we need to monitor the effectiveness to ensure that if there are any changes or any gaps that we can address these. And most importantly, we need to update the procedures if this is applicable. So if there was a non-conformance event, we found that potentially in our procedure, there was a gap that we have to fill. We have created a corrective action. We've told everyone in the lab that we will do this from now on. It's really important to then update your official documentation. So things like your SOP and job aids. Okay, so then there is assessments. So this can come in the form of internal or external. There are things such as internal audits that we can have a look at. And this is very different from the management review that we had spoken about before. So the management review is really looking at the process for specific tests. Whereas having an internal audit, you have someone from a different department come in and they get given a certain set of prompts and they will look to see what the procedure is from an outside point of view rather than a managerial point of view. So this is a very good way to have a look. We need to plan and schedule these to make sure that they happen. And the idea is to observe, interview, and record, have a look at the record review. Writing the audit findings and some non-conformance reports sometimes might come out of this. And most importantly, we have audit follow-up. So if you have an internal audit and you find that in the findings, maybe people aren't wearing the safety goggles or something like this, it's really important that there are follow-ups to ensure that this practice gets put back into place. Other external assessments you have, there are external audits, so very similar. Sometimes you can have external bodies that can come in that will help, particularly those who have undergone the ISO accreditation. There'll be a lot of external audits that came in through that. There's also external quality assessments or proficiency testing. So the PPTC EQA that a lot of people have been part of, this is a type of external assessment as well. The good things that come out of these assessments, you can respond to the findings and also have corrective actions. And this benefits for accreditations for patient care and also laboratory credibility. Then another QSE is process improvements. So to have these, you can implement the corrective actions or preventative actions that we got from some of the other elements of the QSE. There are continual improvement activities. So the lab needs to ensure that we keep having these. So whether it be the process improvements or if it's continuing education, some type of improvement for the lab and to continuously have these throughout the year would be very good to ensure that the lab keeps on improving and is still fit for purpose. We want to support innovations and continuously improve through technology adaptation. So very similar to what we discussed with the consumable and inventory management. And we want to ensure that the laboratory processes and still fit for purpose. Customer service. So although we work in the laboratory, we also have customers. So we want to ensure that the laboratory processes meet the customer needs and expectations. We want to regularly review the processes to ensure that they meet the needs of the patients, clinicians, and other stakeholders. So again, new technologies, pathogens of interest. So if the clinicians are asking you about a specific pathogen and you're wondering, okay, well, we don't really test for that at the moment, it's really important that number one, we find a way to satiate or meet that requirement. So for example, if you're not testing for flu at the moment, can you refer that sample to someone who does? Antibiotics. So this is one that I wanted to highlight because sometimes clinicians might prescribe something to patients that hasn't been tested in the laboratory. It's really important for us to actually review what we test in the laboratory and that it's consistent with what the clinicians are using to treat the patients. So having that regular review process will ensure for good stewardship. Using customer feedback to drive service improvements. So if you're getting some complaints, it's really important to actually listen to these to see how you can improve your processes and improve like patient and customer satisfaction. And lastly, to ensure the services are timely. So this is a very important one. Facilities and safety. So laboratory designs and workflow considerations, as you know, it's really important. We need to make sure that the facility is fit for purpose. So for example, I keep saying fit for purpose, but it's, for example, if you are looking at more pathogenic organisms, so for example, like Burkholderia pseudomallei, it's really important that you have some conditions or infrastructure in your laboratory to handle that organism safely. And so this might be a biosafety cabinet or the level of biosecurity in your laboratory. We have protective equipment, so PPE requirements. This also includes things like waste management. So whether it's biological, sharps, or chemical, ensuring that we have the procedures for this. and emergency procedures, so spill response, fire, power failure, and also environmental monitoring, so temperature, humidity logs, but also pressure and airflow pressure in the laboratory. Another one that's really quite important that I feel like doesn't get spoken enough about is actually laboratory preparedness. So things like stockouts, having plans for when there are stockouts. So for example, if you were running out of agar, and it's really important to have a procedure in place that you have specific specimen types that you would put ahead and mark as more urgent. So for example, you would process blood cultures instead of your genital swabs. Sorry. So all those that we mentioned just before are part of our QSEs. So all the elements that make up our laboratory quality management system. And at the end of the day, it's really important for us to have these systems in place because it all impacts the laboratory path of workflow. So last session, we spoke about our pre-analytical testing. So that would be having our test ordering, specimen collection, specimen transport, specimen receipt, accessioning, and processing. This was really important because last time we spoke about specimen rejection criteria. Then we get to the analytical stage, which is the test method selection, when we want to perform our tests, results review and follow up, and also laboratory results and interpretation. And lastly, it's post-analytical. So these are communication of alert values, so your results, release reports, and specimen management. So as you can see, all three of these elements of the laboratory path of workflow is impacted by what we do in our QSE. So all 12 elements of that is really important for us to get those elements correct so that the laboratory path of workflow is seamless. So LQMS is a difficult subject to talk about because it's quite dry, it's quite boring. So that's why hopefully that wasn't too much of a bore, but it was just really important to just highlight some of those quality system essentials, the QSs. So with that, this is a funny little comic that I hope brings you guys a bit of joy before we move into our next part of today's session. So here's a gram-positive bacteria, and he wants to be positive, but the gram-negative bacteria does not want to be positive. So I thought that was quite fun. I also can't see anyone's faces, so I can't tell whether you guys are laughing. All right. Okay, so that was laboratory quality management systems. I will take some questions at the end, but for now we'll move on. And what we'll move on to is quality control in microbiology. So what is quality control? So quality control is the process of monitoring testing procedures to ensure that the laboratory results are accurate, reliable, and fit for the intended use. Some key elements are testing and known control, whether it's a positive, negative, alongside our patient samples. It's important because we want to monitor the analytical performance of whatever we're testing. It can be used to detect the errors before results are released, and it ensures consistency and reliability of the results that we're releasing. We can take corrective action for when results fall outside these acceptable limits, and it also ensures that consumables are stored at appropriate conditions. So we hear about quality control and quality assurance often, but what is the difference between the two? So in quality control, it really detects the problem. So it focuses on detecting the errors during testing, and it's more useful for day-to-day monitoring. Things like control samples, we can use QC charts, so like Levi-Jennings, and also instrument checks. With quality assurance, the focus is a little bit different. It's used to prevent problems. So for example, it focuses on preventing errors across an entire testing process. It tests the overall quality management system, and the things that it tests can be like SOPs, so your procedures, and it identifies training opportunities as well. So in quality control, we're really detecting a problem for a specific test, whereas in quality assurance, we're detecting we're preventing problems because we're looking at the errors across an entire process. So what types of QCs are there? So there's internal QCs. So this is performed within the laboratory. You can run a control with each batch test. There are things like temperature monitoring for the equipment and also instrument calibrations. There are process controls, so having a positive and negative control, and these can be things like growth control and sterility control. There are procedural controls, so these are built into the actual test method. So for example, it's very common in automated analyzers. So for example, your Vitek, Phoenix, or GeneXpert, they generally have an inbuilt QC. And also, this is done not as frequently, but environmental monitoring as well. So some sterility can happen as well. So now we're getting into the nitty gritty run for what. So non-selective media, we will have a positive control and a negative control. And what we're in non-selective media, for an organism that will grow, so a non-fastidious organism. Our negative control will be an organism that will not grow. So, for example, a fastidious organism. More importantly, we also need to look at the sterility because with agar and media, it's really important that our starting product is sterile to begin with. The second example is our selective media. And this is selective media that we look at when we want to look at characteristics. So a positive control will be an organism that will display characteristics expected for the specific media type. So for example, having a lactose fermenter or a non-lactose fermenter. And negative control will again be an organism that will not grow. And again, it's very important to have sterility for all media types. A different type of selected media is when the selected media has a pathogen target. So the positive control will be an organism that will display the characteristics expected for the media. So for example, a color change. And more importantly, we need to include the pathogen of interest. So I'll give you some examples a little bit later on. The negative control will be an organism that should be inhibited. Okay. And then lastly, sterility. Liquid media, it's a little bit different because there isn't quite such thing as a negative control depending on what type of liquid media you're looking at. If you're looking at things to enhance growth for specific types of organisms, most of the things will go turbid. So it's quite hard to actually have a negative control for some liquid media. But a positive control would be an organism that will grow and also sterility. So QC testing for commercially prepared media versus in-house prepared media, there are some specific differences in the QC organisms that you might pick. So all these rules will still apply to the commercially prepared media, but sometimes with our package inserts, they will actually give you suggested QC organisms to run. So specific ATCC strains that are suggested from that specific company. So those are small things that you need to keep in mind. If you don't have the ATCC strain that they are mentioning, you can also find an in-house QC strain. So for example, if they were looking for a carbapenem resistant organism and you don't have their specific ATCC strain, you can find one in your laboratory that you might keep and that has a similar characteristic they can use to confirm the media as a positive control. There's a lot of different lot-to-lot testing requirements. So for example, if you have different lot numbers for the same media type, you would have to run a QC per different lot number. So this is a lot to remember, and it's probably hard without key examples. Oh, and also lastly, CLSI, the M22 has specific requirements for media QC. So if you ever need to read up on some additional information, the CLSI M22 also has these available for them. So these are some examples of some media types and the QC requirements. And how I want you guys to have a look at this is to look at the media type and see what the purpose of that media is. And that will actually determine what type of positive and negative control that you pick. So for example, for horse blood agar, this is a non-selective agar, and the purpose is for routine culture. So what we want to have is a non-selective organism, so anything that will grow, a positive control. So I've just put in staph species or E. coli. And then our negative control will be something that's fastidious, that won't grow on the horse blood agar. So things like, okay, maybe not Streptococcus species, but like things like Haemophilus species that won't grow on our horse blood agar. In our nutrient agar, it's non-selective as well. It's routine culture. We will actually also see less characteristics on nutrient agar. So for a positive control, anything that grows, something that is a non-fastidious, and then a negative control, the Streptococcus species. Some of them won't grow, and then Haemophilus is definitely won't. So in a soy will really do. And the reason why I've chosen tryptosoy broth as an example is because some labs are using the modified SIM method, so the MSIM, and that uses tryptosoy broth. So if I was in a lab that uses the MSIM method and we will have the tryptosoy broth, I would pick organisms that I would routinely use to do MSIM as my positive control. So just to ensure that the organisms that we're expected to put into this broth will grow in that medium. So MacConkey agar, it's a selective medium, and our primary purpose is to identify it between a lactose fermenter and non-lactose fermenting colonies. So the positive control, there will be two. One will be an E. coli, which is a lactose fermenter, and then the Pseudomonas aeruginosa, that is a non-lactose fermenter. And so the reason why it's important for us to put both of these as positive controls, it's because they give us the different characteristics required. So when we have our lactose fermenter, we can see that, okay, this selective media can detect lactose fermenting colonies. When it's a non-lactose fermenter, we can say, okay, this media can grow non-lactose fermenting colonies. So we're testing the actual purpose, the use case of this selective media, rather than just having a look at, yes, positive is growth, negative is no growth. A negative control can be literally anything that doesn't grow in the MacConkey. So for example, your staph species. When we have selective medium looking for specific pathogen targets. So for example, our MTM, it's a selective media looking for Neisseria gonorrhea. Our positive control needs to be Neisseria gonorrhea because we are using that medium to detect gonorrhea. Negative control can literally be anything. I've put E. coli because oftentimes we are looking for gonorrhea in genital swabs, and in genital swabs regularly we have E. coli. There are other more specialized media. So for example, some chromogenic agar, which changes color and also selects specific pathogen types. So it's a selective medium, and the purpose is to isolate carbapenem-resistant organisms. So what's important here is for us to detect a CRO. So a positive control would be a Klebpneumo, that is a CPO, carbapenemase producing organism. And then a negative control should be the same organism or something similar, a Klebpneumoniae, that is not a carbapenem-resistant organism. And that way we can tell that it is selective for CROs, but also we'll be able to tell the defining features of a Klebpneumoniae. And so with this one in particular, because this is a specific brand of this media, this package insert of this media type will tell you exactly which organisms that you should be testing as a positive and a negative control. Okay, so looking at SAB agar, so Saboreal dextrose agar, it's a selective media and is usually used for fungi and yeast. And so for the positive control, you can have a yeast and also like a fungi of some sort. I've just put it Aspergillus. Negative control would be something like E. coli because we're not expecting the E. coli to grow. Chromogenic agar, again, from the specific brand. So they'll tell you exactly what type of positive control to use. But this agar is only used to identify yeast. So I want you guys to take note how some of these I've written isolate and some of these I've saying identify. The reason and the difference between the two is that for the SAB agar, we're looking to isolate yeast and fungus from a primary sample. When we have things like chromogenic agar, we can actually identify what type of yeast based on the color. Okay, so knowing that there are different colors representing the different candida types, you would have to test multiple candida organisms on that one QC plate. So, for example, our our albicans is green, our glabrata is purple, and tropicalis usually is like a bluey green color. So knowing that the different candidas will produce different color changes, we need to test multiple candida on that one QC chromogenic plate to ensure that there are some variations in the color. So we can confirm that this plate is behaving like it should. And for the negative control, we can just put an E. coli because we're not expecting the E. coli to grow on a yeast plate. So now we're moving on to antimicrobial susceptibility testing QC. So why do we do this? It verifies the accuracy of the AST results. The AST QC should include antibiotic discs, our gradient strips, so you like your E-tests, but also any phenotypic tests that you might do. So for example, the carbapenem inactivation method. The frequency of QC testing will depend on the QC testing schedule. So this is, for example, weekly QCs. At a minimum, you should have your disc QC and also gradient strips. And so the reason why it's weekly is that in some package inserts for these antimicrobial discs and gradient strips, it actually tells you that some of the discs, for example, loses some of its efficacy after a certain time. So after you open it for a certain time, it actually starts to degenerate a little bit. So it's really important to do QCs to see if it's dropping. A test is performed and per new lot number and a per new shipment. So if you run e-tests infrequently, let's say once a month you do a vancomycin MIC, it makes no sense for you to run e-tests for e-test QC for vancomycin weekly because you're not actually releasing any results using vancomycin. So that's why some tests or gradient strips that you don't use frequently can be done as you are doing a patient sample, but you would only release that patient result after that QC has passed. So the frequency really depends, which is why it's really important to have a QC testing schedule because each lab has a different need. So therefore the schedule should be different. In the M100, you'll be able to see the ATCC reference strains that you need to test for specific antibiotics. It also highlights the acceptable QC ranges for the disc diffusion and MIC methods. So if you have time, it would actually be very good for you to familiarize yourself with some of the content that is in CLSI M100. The documents on you need to document the AST QC results. So it's good that we have a QC schedule and it's good that we run QC, but it's really important to have some documentation on these QC results. And what that can look like is something like this. So this is just an example that we made for one of our partners, but pretty much it tells you the date, the antibiotic, what lot number of your testing disc, and which expiry, which ATCC strain that you use to test, and also the acceptable range. So the acceptable range can be derived from the M100 documents, and then you have your results. It's really important to have something like a pass-fail, because when you do some corrective action, or if you're looking at specific components of your QC, you can automatically filter the antibiotic, and also whether something's passed or failed. So that if we do have corrective actions from a failed QC, you can filter the antibiotic type and pass to see when was the last time this QC actually passed. And then if the last time you saw it was a fail, then you can see what the corrective action was. Okay, so to see if it was repeated. So in this one, on the 20th of March, we did a cefoxitin disc. It had failed because it's outside the range. The person who did it was RS, and then the corrective action was repeated QC, see results below. And then so the next day, you can see that it was done and that it was within range, and now it's passed. So corrective action forms should be used to assist troubleshooting, and we'll go into that a little bit later. So with the test QCs, so biochemical tests and stains, it verifies the accuracy of the biochemical tests and the stains. So QC requirements are a little bit different depending on the tests, but for biochemical tests, I'm talking about things like indole, oxidase, or catalase, and it's really important to have a positive control because these are organisms which will provide your positive reaction, and then a negative control, which will be organisms that will provide a negative or no reaction. And so with most of these tests, they come with a package insert that will tell you the ideal positive and negative control. But if it's absent, then we can just do some research and see which ones are always positive and which ones are always negative. Stains are a little bit different. So we have positive controls. So again, organisms which will provide a positive reaction. But having negative controls, it really depends on what type of stains you're looking at. So I've given 2 examples in there where India ink, you can have an organism that will not take up the ink. So for example, E. coli. A ZN stain, organisms will not stain as AFB. So you can have some negative controls which are mod ZN positive, but are ZN negative. So those are generally really, really good to have. But if not, you can just use something like an E. coli. So the frequency, again, it depends on the consumable type. So whether it's a biochemical test, you can do it daily, particularly if you make it up. So for example, in the lab that I work in, our oxidase is a powder form. So every day we will have to make up fresh oxidase. So the oxidase is just the powder mixed in with some sterile water, but this is done every day. So our QC for oxidase is performed every day. So it really depends on what type of biochemical tests that you have and how they come about. So short tests, you can do them daily. Identification kits, you can have them monthly. So these are things like your API kits, or even some of your Well-Cox antigen kits. Those can be done monthly as well. Your stains, your infrequent stains, you should be doing them per test because like I said with the vancomycin MIC example, if you're not usually doing a specific stain and the reagents are just sitting there for a couple of months before you use them again, it's really important that you run them at the same time as your patient sample to ensure that the stains are working as they should. We should do them per every new lot number and also per So examples that I have on the screen are, for example, your Vitek or your BD Phoenix. The calibration is not only just in the instrument, but also any accompanying accessories. So things like in nephelometers. So the nephelometers are used to determine what McFarlane and how turbid a solution is or suspension is. So you can see here the Vitek comes with a density check. So that also needs to be calibrated and QC'd. And same with calibration for the nephelometer for the Phoenix as well. There are also temperature checks. So this is something that we haven't really mentioned, but most of the labs, I know that in Cambodia, we're quite good with our LQMS, so that there's always a temperature log that we look at daily. But this also exists for our analyzers. So analyzers particularly the Vitek, you can actually record internally in the machine what the temperature is. So the quality controls that we need to look at are things like our consumables. So with the Vitek, you have the Vitek cards. With the Phoenix, you have panels. With the MultiToF, you have calibration spots and slides. And so depending on what actual instrument you use, the ATCC strains required can be found in the package inserts. So when we're looking at disk diffusion and our e-tests, we can find which ATCC strains in the CLSI guidelines. But for consumables, for our instruments and analyzers, we will find that information in the package inserts. So it's very useful to go and have a look at them. Unlike some of the other tests that we spoke about where the ATCC strains might be missing and that we can find a internal in-house QC to mimic the same reaction, that's not the same case with our instrument and analyzer QCs, because all the instruments with the consumables, the QC is used to actually test different parts of the consumable itself. So if we use the Vitek, for example, having the cards for QC, they actually ask you to do QC for 3 organisms per card. And the reason for that is because the 3 organisms have very different characteristics. And so the different characteristics will be used to test the different parts of that same card. So the results that it gives you are different. So the in-house QC trick doesn't really help. It doesn't really help with instrument and analyzer QC. There's also internal system QCs inbuilt in the consumables. So both the Vitek and Phoenix, they have a growth QC. So if there is no growth in one of the panels, they actually reject the whole test. So that also is another form of QC. The frequency for these analyzers will depend. So per new lot number, per shipment, once a month for the consumables, only if it's infrequently used. So if your machine is there not frequently used and collecting dust, you might be able to get away with some of the not doing it as frequently. But it's really important to at least do it once a month if you're not using it often. For labs that are using it often with a high throughput, you probably only need to do QC per new lot number and per shipment. Lastly, we want to do our QC following a maintenance or system update. So after engineers come and touch our machines and do some maintenance, sometimes it's good, sometimes it's not so good, and they need to come back and fix it. So in order to find out sooner rather than later, doing a QC after that update is very important. Okay, so QC frequency and schedules, I guess that these are some points that are more generalized. I think depending on the type of consumable or reagent, we have already gone in with a bit of detail with what the expectation really should be. But as overall generalized comments, daily QC requirements for stains are quite important, and also other critical equipment temperatures. So things like your fridges and freezers. Per batch QC, this can be things like your media, reagents, and new lot number and new shipments. So these really depend on the frequency, and it really should be driven by how these tests are used in the laboratory and what's in the schedules as well. So it's really important to ensure that there's a QC schedule and maintenance forms to document QC completion or corrective actions. QC documentation and record keeping. So what's important to document? We have our results, date, the operator, lot number, and expiry. Where do we document them? So we can do either paper-based or electronic QC records. So the example that I provided you before with the Excel, just having a really clearly labeled when was it tested, what was tested, with what ATCC strain, who was the operator, and whether it passed or failed. That's really important information to capture and very easily done on Excel. However, because Excel is highly modifiable, so it's not the best way to do it, but if you didn't want a paper record, having an Excel is quite useful for filtering. We can retain for corrective actions and troubleshooting and for audit and accreditation as well. And lastly, having some trending data, so using like something like a Levi Jennings chart could be useful. It's definitely more useful in situations like if you're working biochemistry. Mr. Vrak had actually made an Levi Jennings chart, and that was quite useful to have a look at the overall picture. So it really depends on, for example, if you needed to be reported to upper management or something like that. But otherwise, having an electronic record is good enough. Okay, so QC failures, recognitions and response. So results outside acceptable ranges require immediate action. Do not report the patient results until these are resolved. So this is an example of what it might look like if your QC has failed and what you should really be trying to do next. So day one, our QC has failed, so we want to check our reagent and consumables. What are we checking? We're checking things like the reagent expiry and also instrument check. So if there's any internal errors. If you are using an instrument, to check the internal errors is really important because it's not necessarily your QC failing because of other external factors. It could just be your instrument. Another good thing to check here is also when the QC has passed last for that specific lot number. So if you had an Excel spreadsheet that indicated all the different QCs and all the different lot numbers, it will be really easy for you to filter and check when the last QC was performed. We want to check the ATCC strain. If there was an ATCC strain that was used, is it the correct one? So sometimes we have there's a lot of ATCC strains and sometimes it gets mixed up in the laboratory. So ensuring that the correct ATCC strain was used is really important. And also, is it a fresh strain? So has it been freshly subbed out? Is it less than 24 hours? That's something that you need to think about. After we check these, we can then repeat the testing. Okay. Lastly, we want to fill out a QC correction action form with the above details. So the form will have today's date, exactly what you've checked. You've checked the consumable, you've checked the ATCC strain, and then you've also repeated testing. All these things should be in your QC correction action form. Okay, so the next day you come into work and you check your result. If it's still failed, you want to notify a senior staff or your supervisor, and then you want to document your QC failures. So what was your result today? Was it the exact same as day one? Was it a little bit better? What changed? After you do this, depending on the type of QC you're doing. So if it's an AST, you want to resub the ATCC strain to ensure that it's the correct one. Because if at day one, we checked the ATCC strain, it was labeled correctly, but the wrong one was picked up when we were actually performing the test, then on day two, we want to resub the correct ATCC strain. So when I say resub, I mean take it from the freezer, okay? So not the one that's sitting in the fridge for 2 weeks. We want to take it straight from the freezer. The reagents, so if it's a reagent QC, you want to test with alternate strains. So for example, if you had an indel test that failed QC with the E. coli 25922, you can try it with a Klebsiella oxytoca and see if that passes QC. So we want to fill in the QC correction form with the above details. So the idea is every time you work on this specific QC that has failed, every single detail that you have, you want to always update that QC action form. So at day 3, repeat the testing with the fresh strains. Fill the QC correction form with the above details. So if it came straight from the freezer, you would actually have to sub it again for an extra day before you can repeat the testing. Because it's not so good to repeat things straight out of the freezer. Sometimes you can be cheeky and see if it works, but it's actually best practice to wait an extra day. And day 4, we want to check the results. If it still failed, you want to notify senior staff or supervisor. So the reason why it's really important to notify supervisor or senior staff early on is usually they know something that we potentially don't on the benches. So whether it be some communication from the supplier, like that there's been a recall of this antibiotic, or if there was something that they've experienced in the past, or they've noticed that this QC has been failing for the last 3 tries, it might actually come down to the consumable itself. So let's say your amikacin disc keeps failing, and then only the senior scientist knows about it, because everyone, it's part of the procedure to tell the senior scientists every time something fails more than once. So they'll be able to give you a bit more guidance, hopefully. Okay, so at day 4, we want to check our results. If it's still no good, we tell someone. We then will repeat the test with a new batch or new lot number. So if this was a amikacin disc, it's maybe halfway through the vial. We will then open a new vial of your amikacin discs and try this. So the first one is to open just a new one from the same batch. If that doesn't work, so if that still fails QC, then we will then do a new batch or lot number. So it really depends on what type of QC and how frequently you sub out your isolates. So this is an example of what it might look like when you're trying to troubleshoot a failed QC. But the most important takeaway message is to fill out the QC correction forms, because the QC correction forms is good for traceability. It's good for traceability for if you weren't coming into work tomorrow and someone needs to take over, they know exactly what has been done, so they don't have to repeat the same steps. But it's also good for in the future if there are things that happen in the same case. So if it was the same antibiotic, for example, you could actually go back and see how was it resolved, and you can jump straight to that same resolution. Okay, so that brings us to the end of our presentations. I think maybe I'll open up the floor to you guys for any questions before we continue on to the next activity. I know that today was a bit full on. I think there was a lot to take in, and the LQMS is a little bit dry, but I think it's a really good opportunity for us to do some discussions for QC. Yep, Rexa?
Hello, Kelly. Do you hear me?
Yep, I can hear you great.
Okay, thank you your presentation, but I have one question related to the QC. Based on our experience, we had to concern that after we had to
No, so I've written here that QC testing for commercially prepared and in-house media is equally as important. So the reason why is because I know where the confusion comes from, because when you buy commercially prepared media, you are assuming that they have already done QC. And so the question really is, okay, so since that company has already made or performed a QC, do we then need to do QC? And the answer is yes. So the reason why we want to do QC, have you noticed that a lot of the times the frequency of performing QC is after shipment or after new lot number? And so if you perform QC after you receive your AGA from a different company, this is important because it ensures that that transport from that company to your lab was appropriate. And so let's say for media, for example, we want it to be fridged. They should be in a fridged temperature, and particularly in Cambodia where things are quite warm, it's really hard to maintain that temperature control. And so that's why it's really important that when you have received that media into the lab, to perform that extra QC step again. Does that make sense?
Finally, that we ensure that we should do the QC or not.
Yes, you should definitely.
You can recommend
you should definitely do QC
Okay,
still.
yeah.
So, like I said, it just
mhm.
ensures that the media was transported in an appropriate temperature, and that nothing changed during transport, so nothing denatured, and that everything is working as it should. So, still really important to do that.
Okay, thank you.
No worries.
Just a follow-up question. Is it necessary requirement or just like like uh something that we can do or like what I can say alternative or something? Like
Yeah,
it
so
a requirement or not?
Yeah, so it depends on how your laboratory is governed. So if you were doing going through accreditation, then yes, you definitely need to. But if you don't want to be accredited and there's nothing really governing you, then you don't. But it's not very good lab practice. So we
Yeah.
were talking about our quality system essentials, and one of them is inventory management. And a lot of it comes from like, QC and things like that, and making sure that your consumables are working as they should so that you can provide the reliable results. And so that's why, even though it is a requirement if you're looking at accreditation.
This meeting is being recorded.
Còn lâu chứ.
I have one question.
Oh, sorry, I thought that was the old hand, Rexa.
Okay, based on your presentation, I saw that you have to present about the type of the organism for to do the QC, but I not see the number of strength which with the ATTC strength that we had to use, or we just only use the organism for to the QC and not to can you clarify on this? Yes.
Yep. So the reason
Thank you.
that's okay. So the reason why I haven't put exactly which ATCC strains to use is because I want to give you the flexibility, because I know that, for example, having all 5 different Canada ATCC strains is extremely difficult to obtain, and it's not useful for all labs. And then so having just the organisms there will just give you the flexibility, and it's more to illustrate to like you understand why these conclusions have come about. So, for example, like I said, if you wanted to look for specific ATCC strains per the different types of media, you can go back to package inserts. So, for example, for those who are making media in-house, for all your media powder, they will come with specific QC requirements, and those ones will have ATCC strains on them. So you can always find them. This is more just an example to show you how these decisions come to play.
Okay, thank you.
No worries. Yeah, Sana?
Thank you, Kelly, for the presentation. And I have a question related to the in-house preparation media or reagents, including with the commercial reagent that didn't have the expiry date. So do you have any idea for like how long that we should keep in the lab for the expiry dates?
Yep. So so my favorite thing is the package insert. So if you are making them in-house with all your package inserts, it actually should tell you how long you can keep them for. So generally for non-selective media, you can keep for up to a month, but it really varies on the type of media that you're looking at. So those that are more selective, so for example, your chromogenic agar, like your, supercarba or things like that, they actually have a much shorter shelf life. So you can still culture things on them, but the characteristics actually start to not show anymore. So, for example, with the Candida, when I was telling you guys that the different Candida species will give you different color, over time, they will actually lose all those properties in the media. So usually chromogenic agars will be a lot less, but it's really important for the labs themselves to actually identify this. So one of the labs that we worked with in the past, they actually tried the Chrome Agar M Supercarba. And so in the package insert, it actually said that it was good enough for a month. So after you make the media, you will still see the color after a month's time. But actually, they noticed that there was a color change or no color was developing after I think 4 or 5 days. So it's actually very different from what the package insert says. So when you are doing things like in-house media, it's really important to have that validation step embedded when you first bring in some media. But the answer to your question is really looking at the package insert. And if you're buying them commercially, the people that you're buying them from should give you an expiry date.
And yeah, thank you, Kelly. And how about the commercial reagents such as in the end, they will buy from the company didn't have the expiry date. So should we create our own expiry date or something else? And if we create by our own expiry date, and how long you prefer for the expiration?
Yeah, so it's very different depending. So like India Ink is a bit special because it actually doesn't have an expiry date. So what you need to do is,
Yeah, like some in the ink that we buy the expensive one is have the expiry date, but some is not as well.
Yeah. So this is where it's important to run QCs. So remember how I think in one of the and so in here with the India Ink and things like that, it's really important to do it more daily. So things like per test or daily. So if you have do you have a Cryptococcus QC or like a Cryptococcus stored?
Yeah. We
Yeah.
have usually we do the QC, always do the QC, but for some internal audit, they need the expiry date for the reagent as well, because we didn't have in the commercial in the yeah.
Yeah, so if they don't have a expiry date, it's really important to run the QC in parallel to your test. So for example, if it depends on the frequency of when you're getting these requests. I know for my lab, it's quite rare sometimes, and having that Cryptococcus may be just handy in the incubator that you can just take out and run the QC as you're doing a patient sample. That should be enough to give you that confidence that it's working. But it is tricky when they don't give you an expiry. But doing that daily QC will give you that confidence that it's still working as it should. Does that make sense? Because in a sense, you can't really run the QC and then say that, okay, this is going to work for the next 7 days, particularly if it doesn't come with a manufacturer expiry date. Does that make sense, Suna?
Sorry, because my English lower, so I difficult to say about my question. Like for my lab, for our reagent that we in-house reagent that we making, usually we create the expiry date like 1 year for expiry dates. And I want to know this is appropriate expiration or not.
Honestly, it depends on what it is. So it depends.
For the QC is we run daily, and also QC is passed already also passed as well. But for the I just want to know the creation of the expiry date for some reagent that we making in-house or some commercial reagent that we bought but didn't have the expiry date. So should we create the expiry date for how long, like 1 year or 6 months or 3 months, something like that?
Yeah, so it depends on what type of reagent. So let me give you some examples of what you should consider before you give it expiry of 1 year. So things like you need to check sterility. So if you have things like, can you give me an example of what type of reagents you're making?
Like for lactophenol blue reagent, something like that didn't have the expiry dates on the yeah.
Yeah. So
So we
we'll
check the
go-
QC, we do the QC and pass, but some like the audit they still need the
Expiry.
expiry date just for the reagent as well. So
Yeah.
I just want to know your experience would we create like how long, 1 year or 2 years?
Yep. Yep.
Yeah.
So 1 year is a safe bet for things like the lactophenol blue, especially if you're doing QC. So how this usually comes about is you actually normally would do things like sterility. So ensuring that, you know, whatever reagent that you're making can be sterile to up to that year. And so with things like the stains, you're not expecting the sterility is important not because we're growing things in it, but so that when we introduce things to count, for example, that it's not going to be interfered by other things that are growing inside. Does that make sense? Or whether it's like moldy or like something like that. So usually with stains, they're quite good if they're not exposed to sunlight. So that's like another factor. So there's many different factors that you would consider before you give something that doesn't have an expiry date. But as long as you're doing the daily QCs, I think that is okay. How long have you had the phenol blue for?
Usually we do the really just only for the identify for fungal, so it's not much for
Yeah.
testing.
Mhm.
And also we do the QC like monthly QCs for
Mhm.
that reagent. Yeah.
Yeah. Okay. Well, if you're doing a monthly QC, and let's say that it's kind of like a trial and error as well. So, for example, if you've given it a expiry date up to 1 year, after 1 year, if you use it and it still works, then your expiry date of 1 year is a good guess. Does that make sense?
Yeah.
Yeah. So it really
Yeah,
depends
that's
on.
yeah. And if like we do the 1 year later, if QC is still passed, so we will extend the expiry date. Yeah, expiry
Yeah.
expiry date again. Yeah.
Yeah. So
And so I'm not sure this is like quite. Would you have a like if you have like experience? So I would like to know about this. So we should extend for 2 year or 5 year if
yeah.
the QC pass, or we have said, oh, this one just only related only for the QC. If pass is okay, no need for expiry date.
It's having an expiry date, it's good. But what I'm concerned about is, for example, if you do your QC after 1 year, I don't think you should be extending the life of the expiry of the same batch number. Does that make sense? So once you hit that 1 year, you should throw them all out. Does that make sense? So that you will always have somewhat of a fresh reagent, even though it's lasted a year. Does that make sense? So whenever you create media or reagents, there should always be a batch number associated to whatever you're making, and that batch number should always be associated with the same expiry date. And then that way you can trace whether something works or something doesn't work. I think what might be useful is, do many people still make their reagents and media?
For my lab, we make our media in here. Yeah, except for the blood culture bottle that we bought from the companies.
If it's useful for some others, what I might do is I can get a guest speaker to come. This is very privileged of me, but I've never actually had to make media before. So I can ask a guest speaker to come, and then she can probably answer some of these questions a little bit better.
Oh, can usually for the media and that we make for QC is okay. We have no problem, but
Reagents.
just only
Yep,
yes.
no worries. That's okay.
Just want to know about the like some chemical reagent that didn't have the expiry date from the commercial. So I think it's okay to use rather than like we always should have the creation expiry date by our own or not.
I think it's generally okay. What I might do is I'll get back to you, Sona. I'll put the answer in the Telegram chat. I
Okay.
think I'll talk to some of my colleagues who have a bit more experience with this type of reagent making, and then I'll let you know.
Yeah, thank you so much.
Yeah. No worries.
Yeah.
Great. So Rex has got a few questions in the chat. So what are different between the internal assessment and internal audit, and are they the same? And then another question is to use reagents expire date after performance that passes QC. Okay, so the first one with the internal assessment and internal audit, they're slightly different because an internal assessment would refer to people in your own department assessing a procedure. Whereas internal audits, they should really come from people from a different department within your institution. So, for example, at NIPH, an internal audit can be performed at the microbiology lab by someone in virology, for example. So, someone who doesn't know too much, a fresh set of eyes, but knows enough to assess a laboratory component. So things like safety or things like, a specimen management or something like this. An internal assessment would be things like procedural assessments. So ensuring that we have the people are compliant with how we're reading our plates or how long we're keeping things for. So things like that. So a little bit different, but very similar in a way. Both are assessing the laboratory. The other question is, some reagents are expired after performance past the QC. The answer is yes, but we need to be very careful, and the QC needs to be performed every single time a patient sample is being performed as well. So depending on the type of reagents, so for example, if it was like an oxidase or something, you would be doing an oxidase at the start of the day and then per each patient sample that you're doing. Similarly, if you were to run a expired meropenem disc, you would have to run the meropenem disc QC across all different bacterial ATCC strains. So on the CLSI, you will notice that there is meropenem breakpoints for QC for both E. coli and Pseudomonas. So you will be running the E. coli and Pseudomonas and your patient sample. So you would only accept your patient sample results if your E. coli and Pseudomonas QC passes. Does that answer your question, Rexa? Okay, great. Okay, so is there any more questions? We have 3 minutes and I would like to start our breakout activity. Okay, no questions? All right, so our breakout activity is really just to understand what QC is like in your laboratories and how do we do troubleshooting and how frequently does it fail. So you'll be assigned to a breakout room with your members to discuss the following questions. The first one is about AST. So what QC is performed for your AST? Do you do DISC? Do you do e-tests? What do you do? And how frequently is AST performed? Then there's biochemical tests. So the same question, but for biochemical tests, then media QC, equipment QC, and troubleshooting. But really wanted to have a look at this question 5 because troubleshooting is what will be very useful for this group. How frequently does the QC fail? When the QC fails, what actually fails? And how do you troubleshoot your QC and how is this documented? Okay, so initially I wanted 25 minutes, but maybe we'll just do a quick 10 minutes and see how we go. Okay, so I'll just put everyone in a breakout room. Okay, so you should be able to see your breakout rooms now.